In this video, we're going to be solving some more trig equations, and these are going to have just like a second layer of complexity to them, just a little bit more difficult than the first ones in the last video. And we're going to start with ones that have a second power of sine or cosine. So the first one says the sine squared x equals 3/4, and I need to tell you what sine squared x means. Okay, so sine squared x means we're going to take the sine of x and then we're going to square it. To avoid confusion, we use that notation, even though I feel like sometimes that notation causes more confusion than it solves. But really, the writing in red is what you need to know, that those are equivalent forms. So I'm going to rewrite the expression on the left, that sine squared x, as sine of x squared. And that's going to equal 3/4. And then I'm trying to isolate the sine x. I'm trying to solve for that, just like I was in the last video. So I'm going to take the square root of both sides of the equation. And remember, when we take the square root of both sides of an equation, there's going to be a plus or minus. So I've got the sine x equals plus or minus the square root of 3/4. Okay, now that number might not look familiar to you, but if you think about it, the square root of 3/4 is the square root of 3 divided by the square root of 4. And the square root of 4 is 2. That's saying that sine x is plus or minus root 3/2. And it's like, oh, that's a familiar number. That's the type of number we see on a 30, 60, 90 triangle. So let's go ahead and just like draw the type of triangle that has sine of, that reference angle being root 3/2. And so that's one of our 30, 60, 90 triangles that's kind of positioned in such a way that it's got a 60-degree reference angle. So I'm going to go to the unit circle. I'm going to say, all right, well, if I first think about where is sine x positive root 3/2, that's almost all the way up. That's 60-degree reference angle. So I'm going to go really far up the circle, and I'm going to go to the points that have that y-coordinate, 60 degrees up. And so that's going to be 1 pi over 3 and 2 pi over 3. And so that's going to give me, two solutions to the equation. And then I'm going to think about when sine x is negative root 3/2. Okay, well that, that vertical leg would need to be negative, and that would just, drop the angle down into the third and fourth quadrant. So I'm going to go down root 3/2, because sine is vertical displacement from the x-axis. And I'll see, all right, the points that have that kind of vertical displacement are down there, again, with that 60-degree reference angle. That's 4 pi over 3 and 5 pi over 3. And so that's going to give me my solution set. That's going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And I think that, if I was to zoom out these questions here, they were just asking for the solutions in the interval 0 to 2 pi. But maybe I'll do the first two, 0 to 2 pi, and the second two, I'll just find the general solution. Next one is 6 cosine squared x equals 3. So again, we're trying to solve for cosine x and then figure out what x is, using the unit circle. So just like the other one, cosine squared x means take the cosine and then square it. So I'm going to, first solve for cosine squared x by dividing both sides by 6. And say cosine squared x is 3/6, which is a half. And then I'll rewrite that as like the cosine of x taken to the second power. And so I'm going to need to take the square root of both sides of the equation, and that'll have a plus or minus. So I'll have plus or minus the square root of a half. And thinking about the square root of half, that's going to be the square root of 1 divided by the square root of 2. We're going to rationalize the denominator to make it, something we recognize. It's like, oh yeah, that's root 2/2. This is a number we know. This is a 45, 45, 90 triangle. And it's like, okay, yeah, these 45, 45, 90 triangles, they always have cosine x either equaling root 2/2 or negative root 2/2. So if we think about the unit circle, like cosine x equals positive root 2/2, that's at the pi's over 4 on the right side. And cosine x equals negative root 2/2, that's the pi's over 4 on the left side. So, if we collect all these together, we're going to have x equals 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 is our solutions, because it's just all of the 45, 45, 90 triangles, because, cosine is always either going to be positive or negative root 2/2 on these triangles. Alright, here's two for you to try on your own, with the second power of tangent and secant. So that secant, you can kind of turn it into 1 over cosine squared from the beginning, or do it later on. It really ain't going to matter. I think you're going to be able to solve these. Solutions should be pretty familiar. But you're working with the video pause, because I'm just going to bring in the solutions here in a couple seconds. Alright, there you go. So, these were a lot like the other two, especially in the sense of the solutions they produced. But, isolate it down, solve the equation, think about what kind of triangle we're working with, go to the circle, get yourself your theta coordinates, x values, whatever you want to call them, get your solution to move on. Okay, now the other thing I wanted to show you in this video is multiple argument situation. Like what happens when we have more than just an x on the inside of our sine or cosine or tangent or whatever. And so I think what I would start you off with is thinking about the difference between the graph of f of x equals 4 cosine of x plus 9 and g of x, which is 4 cosine of x minus pi over 2 plus 9. And, you know, if you've been paying any attention at all in AP Pre-Cal, we've done a lot of these transformations. You say, okay, replace x with x minus pi over 2. That's going to be a translation right pi over 2 units. And it's talking about, we just solved the equation 4 cosine x plus 9 equals 5. And, you know, in class when we got to this example we had, and I did solve that one in the last video, and just to remind you what happened, we were going over there, we isolated the cosine, we saw cosine x was negative 1, we found the general solution, it was pi plus 2 pi n. And so the question is, you know, like what would change if we were solving a very similar equation, but it was like, you know, replaced x with x minus pi over 2. It should shift the solutions right pi over 2 units. And I think I'm going to show you that happening on a different window. So what I'm going to do is I'm going to graph f of x equals 4 cosine x plus 9, and then y equals 5, and look at the solutions. And then I'm going to replace the x with x minus pi over 2 and watch it shift the solutions right. Alright, so we've got the graph of y equals f of x shown in green and y equals 5, and you see the intersection points are like negative pi, 1 pi, 3 pi. Like we said, pi plus 2 pi n, where n was any integer. But what I'm going to do is I'm going to turn off the graph of y equals f of x and turn on the graph of y equals f of x minus pi over 2, and see, right, it did shift those solutions right pi over 2 units. It's now negative pi over 2 plus 2 pi n, or maybe 3 pi over 2 plus 2 pi n. That's what we'll see when we go back and look at the algebra. So when we solved the original equation, you know, we said like, I'll call it theta. 4 cosine theta plus 9 equals 5. And, you know, that gave us theta equals pi plus 2 pi n. Now, if I go to solve this new equation, I'm just kind of proceed as usual, isolate the cosine. I'll end up with cosine of this thing, this x minus pi over 2 equals negative 1. Well, now this x minus pi over 2, that's just my new theta. And so I could just say, all right, well, x minus pi over 2, that's theta, that needs to equal pi plus 2 pi n. And then I'll see that if I just solve this out algebraically, that is going to serve to shift all of my solutions right pi over 2 units. I take those x coordinates and I add pi over 2. So this should make a lot of sense. It's just the same as solving it out. And then that negative pi over 2, well, that would just be, on my solution in black, that would just be where n equaled negative 1. And then I would also point out that that 2 pi n in this case did not change, and that would be because the transform, like replacing x with x minus pi over 2, that didn't change the period of the function. If you think about when I showed you the graph, it just shifted it right pi over 2 units, and that didn't change the actual width between the maxima or the minima. And also, you could see that on a combining like terms level, right? I was just adding pi over 2 to both sides. I didn't have anything with an n attached to it, so I wouldn't be able to, you know, change the 2 pi n. But that won't always be the case, you know, like if we run into something that causes a change in the period, like horizontal dilation, like this one, you see sine 2 theta equals 1. Okay, well, just kind of ignore the fact that it's 2 theta. Just think about where sine of a thing equals 1. Go to the unit circle. Okay, that's going to be up at the top, and so that will be where that thing is pi over 2 plus 2 pi n. And then we can just go in and say, all right, well, that thing is 2 theta. And then, okay, if I want to solve for theta, I'll divide both sides by 2. I'll just have to be careful. It'll be half of pi over 2 plus 2 pi n. And I'll need to distribute this over. And so, you know, we'll see algebraically here a good reason to change the number that's attached to the n. So half of pi over 2, that would be pi over 4, plus half of 2 pi is 1 pi n, where n is an integer. This next one's got tangent of 4x equals square root 3. And so I know the tangent ones are always a little tricky, especially at first. But if we see that square root of 3, we know that has to be dealing with a 30, 60, 90 triangle. And so I would just think about, you know, it's opposite over adjacent. The opposite one has to be the root 3 over 2, and the adjacent one has to be the 1/2. So it's going to be one of our taller 30, 60, 90 triangles. Then I go to the unit circle and I think about where's tangent going to be positive. Well, that's where either x and y are both positive or where x and y are both negative. I'm just going to make it easier on myself and just assume that I'm looking at the exact same triangle that I drew off to the side where both x and y were positive. So I'm going to think that's right there, 60 degrees up, that's pi over 3. And then I remember if I'm solving one of these tangent equations and I'm going for the general solution, well, I just need one of them and it's plus pi n. So the thing on the inside of tangent is going to be equal to pi over 3 plus pi n, because the one directly across the unit circle from that original spot that I found that worked will also work just because of the period of tangent. Okay, now I'm going to want to divide both sides of this equation by 4 to solve for x, and then I'll distribute the 1/4, and that'll be pi over 12 plus pi over 4n, where n is just some integer. This next one brings up a situation that I'm not sure we did a very good job of emphasizing in the last unit. I don't think we ever brought it up really. But I'm just going to start by trying to solve for secant squared 5x and then turn it into cosine. So I'm going to start by adding 1 divided by 4. I'm going to take the square root of both sides, so just get secant of 5x, and that'll be plus or minus a half because the square root of 1 over the square root of 4. And then I'll maybe change this into cosine, so it'll be cosine of 5x equals plus or minus 2. And that's going to be a problem for us. If you think back to the graph of y equals cosine x, that's always stuck between negative 1 and 1. Cosine x could never equal 2, or cosine of 5x. Cosine of anything can never equal 2, because it's always stuck between negative 1 and 1. So I'm just going to immediately say no solution. Okay? I know that cosine theta is between negative 1 and 1 for all theta. Now here's one for you if you've thought the first few were too easy. If you've thought those were too easy, try this one on your own with video pause, because I'll just bring in the answers here in a couple seconds. And there you go. So that one had a little bit more going on. We need to take the 4th root, which was going to be the square root of 3, and all that stuff. If you're interested in this one and you didn't really understand the work I've shown here, come talk to me about it. But I think this one goes a little bit beyond the scope of what we're going to have to do in AP Pre-Cal for this type of question. Okay, now the last example I got for you in this video is kind of a contextual problem. We've got the height of a water in a tidal pool modeled by f of t, and so we're going to solve a little inequality with something going on the inside of sine. So we just need to be a little bit careful on this one, and what I'm going to suggest is that we just replace whatever's on the inside of sine with like theta for this type of problem. So if we want to know how many hours the height of the water is above 5/2 feet, we're interested in solving the equation when is f of t greater than 5/2. But I'm going to introduce the variable theta. I'm going to say let theta equal pi over 6t. So that means I've got 2 plus sine of theta greater than 5/2. And I'm just going to isolate the sine, subtract 2 from both sides. And I got sine theta greater than 1/2. So I go to the unit circle and say, all right, well, I'll find where sine theta equals 1/2, and 1/2 is not very far up the unit circle, right? That's the short leg of a 30, 60, 90 triangle. So I've got a 30-degree reference angle is what I'm looking for. So that's going to be right here. So that's going to be pi over 6, and pi minus pi over 6 is 5 pi over 6. All right, so I've got my values of theta. I've got theta equaling pi over 6 and 5 pi over 6. And that's just for, one full tide is the model, so we only need one time around the unit circle. Okay, I'm going to substitute on theta because I know that theta is pi over 6t. And this might be easiest to just solve with your eyes, really. What do I multiply pi over 6 by to get pi over 6? That's t equals 1. And then what do I multiply pi over 6 by to get 5 pi over 6? That's t equals 5. All right. Now, it just asks for how many hours. That's like the duration of the time interval that the water is above 5/2 feet. That's for the 4 hours between t equals 1 and t equals 5. So I'm just going to say that's my answer is 4 hours, and that's how I got there. Okay, so I think that's going to be all for this video. Thanks for watching.